factoring polynomials with more than 3 terms. Alrighty, so if we look back at our chart, we know that there's only one method really that we use when there's more than 3 terms. So we have the binomials, we have the trinomials, and if you have more than 3, then you're going to factor by grouping. So that's the method that we're going to do now, and we learned that in the first section in 6.1. So let's go ahead and practice that now. Factor by grouping. So again, when you have 4 terms, you put parentheses around the first 2 terms, and then you put parentheses around the second 2 terms, and now we find the GCF of each of the parentheses. So let's see, the GCF here, they each have a p in common. So I'm going to take out a p, and I get p squared minus 2q squared. Here they each have a q in common, so plus q. So that means I'll have p squared minus 2q squared. And this should always happen. Always, 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 always. Whatever is inside of both of the parentheses should always be the same. Always be the same. So I'm going to factor that out and get p squared minus 2q squared. And then whatever you have left is your answer then, p plus q. And that would be the factors. Checking out this guy right here. Again, we put parentheses around the first 2 terms and the second 2 terms. Factor out the GCF right here. So 9x squared and 24x. Looks like we can factor out a 3. So 3x. And so that means I would get 3x right here plus 8. And then here I can factor out, let's see here. So it looks like on this guy, 16y squared, there's nothing to factor right there. That's interesting. So it looks like this guy you won't be able to factor this. Now you could do difference in squares, meaning 16y squared is what squared minus what squared. So that would be our 4 and then our y, but that's not going to help us though. I mean we'll get plus 4 plus y and 4 minus y. But yeah, so this guy is not factorable. This guy would be prime right here. Okay. And lastly, for part C, again we're going to try factoring this guy, and let's go ahead and take these guys out right here. And actually, the more that I think about this, let me just look back at this problem right here. Not inclined to start this video over right now. Let me just look at this. If you look at this guy right here, notice that the first 3 terms is a perfect square trinomial. Yeah, so let me just get rid of this real quick. And I'm just going to rewrite the problem here. So 9x squared plus 24x plus 16 minus y squared. Okay, so notice that if I were to group the first 3 terms, okay, it's still factored by grouping. If I factor this quickly, this is actually just 3x plus 4 squared. Yeah, this is a perfect square trinomial minus y squared. Oh yeah, this is pretty rad right here. Now check this out. There's a perfect square trinomial. Now I have something squared minus something squared. This is now a difference of 2 squares. This is pretty nerdy, man. That's what I'm talking about. So you can rewrite this as the first term plus the last term, and then the first term minus the last term. I did like a minus b, a plus b for the difference of 2 squares right there. Okay, let's go down here and see what we got going on with these guys now. So this guy looks a little tricky as well. Now, ooh, all right. So I have a cube, a square, a cube, and a square. Let's go ahead and rearrange these first. So 64a cubed plus b cubed, and then I have plus 16a squared minus b squared. Okay, so I have a sum of cubes, and then I have a difference of squares. So I'm going to be factoring 2 times differently though, okay? So I'm going to factor this guy first, and I'm going to factor that guy. So let's deal with first the sum of cubes right here. So let's see. Can I write the first term as something cubed? And can I write the second term as something cubed? I believe so, right? Let's see. 64a cubed, so that's going to give us 4a, and then b cubed would give us b. So if I factor this, it's just going to be 4a plus b. And then you square the first term. So that's 16a squared minus this product. So 4a and then b. And then plus the last term squared. Okay, so that's what this whole thing is. Now let's do this guy. And this is a difference of two squares. So what squared minus what squared? And this is a pretty crunchy problem right here. So this would give us 4a and then b. So if I factor this, then it's going to give us 4a plus b and 4a minus b. And this, by the way, is a plus sign right here, right? So we haven't factored it yet, right? Remember, the simple definition of factoring is you take a polynomial such as this and you make it a product. So this is not a product yet. Yeah, we have a product plus a product, but we need to get rid of this plus sign if you're really going to factor. So what we can do now is check this out. Notice that each term has a 4a plus b in common. So let's go ahead and factor that out. I'm going to factor out a 4a plus b, and what do we have left? Well, I have my 16a minus 4ab plus b squared, right? Because those are gone. So I have this plus, and then I have this guy right here, 4a minus b. And let's see, can I combine anything together? 4a goes with that, and the b. So some of this can go together. We'll go ahead and clean this up one last line. So 4a plus b. Let's see here. 4a and 16a is 20a. So those guys right there. And then I could just go ahead and put these in order now. So I'll put plus b squared minus 4ab minus b. So, woo! Now this is a product now, which is now this is a factor problem.